Okay, so in the last class, we concluded that like the key to externality policy was information, and that assessing externalities requires collecting the right information. And usually, to assess any externality problem, we need information from many different sources. One set of sources is sort of scientific or technical. And usually these sources of information are best assessed by expertise. And we'll talk about what sort of expertise during this lecture. Some information is sort of more subjective or individual, and it's held by the individuals who are affected. And this is problematic for policy because you need to give an incentive to people to reveal the right information. And so today we're going to figure out how to combine and trade off how much scientific or sort of technical centralized information to use versus how much to try to elicit information from individuals. So we'll start by talking about cost-benefit analysis as an encompassing framework. We'll then talk about how to combine scientific and technical studies with economics. And a key ingredient in that will be the value of human life and health. And we'll apply that to the Stern review of the economics of climate change. We'll then talk about types of useful subjective private information, how contingent valuation surveys provide sort of a relatively naive first pass way to try to incorporate that sort of private information. And then we'll talk about the Vickrey-Clark-Rhodes mechanism, which is a more sophisticated mechanism that tries to incorporate that private information. Okay. So benefit cost analysis is economists' sort of standard approach to evaluating policy. And it's supported by many economists because it lines up well with the way that economists like to think about things. It emphasizes the importance of trade-offs, of sort of pros and cons. And it's applied by economists to a wide range of decisions. And these analyses tend to involve many different dimensions. One is the direct harms on economic resources. So we have to gauge how much resources are destroyed by some sort of an externality causing activity, and then determine the market value of those resources. Second are limitations on the utilization of resources. So if some externality makes it harder to use a resource, you have to figure out what are the value of a resource in different uses and how that's changed by the externality. Third, we can look at destruction of a particular type of resource, which is human life and health. And we'll talk a little bit about how we value those things in a minute. There can also be sort of intangible harms on subjectively valued resources, like cultures or biodiversity or things like that. And one approach is to just take the value of those things directly from ethical theory. That's sort of the centralized scientific approach, but you can also try to derive some of that value from what the value is that individual people put on those things existing. And that requires sort of a pretty difficult problem of eliciting from people how much they value various resources, and we'll talk about that. Okay, so benefit cost analysis is often used to make a variety of big public decisions, such as instituting new regulations on an industry, building a public project in some location, etc. But the approach can also be applied to thinking about externalities, such as determining the right Pigouvian tax. You need to add up all the marginal costs and benefits to figure out what the right overall social marginal cost is that's not internalized. Assessing damages in a court case. So if you're trying to figure out how much externality was created by something, you have to figure out what were the costs that were created by that activity. And economists, one of the main things that economists do other than work as academics, one of the main ways that we make money on the side, basically, is to provide expert guidance on what the costs of some thing that occurred were to the parties that were harmed, so that the court can assess how many damages to award. A third version of this might be that you're trying to figure out what's the optimal level for cap and trade. So what are the marginal benefits and costs of increasing the quantity a bit more? And these analyses are done by academics, by courts who usually hire academics to do them, or by bureaucratic agencies which employ economists full-time working for them to do these types of analyses. And in fact, there was an office, I don't know if anyone's ever heard of Cass Sunstein, but he was a professor here, he moved to Harvard. He set up a whole agency under the Obama administration that did these cost-benefit analyses for all different parts of the government, called the Office of Information for Regulatory Analysis or something like that, OIRA. Okay, so one crucial element in doing any of these analyses is technical. So we have to know what physical harms and benefits actually follow from any action someone takes. And this typically requires detailed knowledge of, among other things, physics. So for example, if you want to figure out what the effect of the Fukushima Daiichi disaster was, so you can figure out what sort of regulations we should have to try to prevent that from occurring, you need to know what the chances are of a reactor spilling over if you have different levels of safety protections, right? Or I don't know if anyone heard of the CERN project, which is this giant accelerator in Switzerland. But there were a lot of people going around the world saying that this could potentially create a fissure in the cosmos, and this could sort of destroy everything. And so you have to know how seriously to take claims like that. You guys can look up online, I won't say it, how people jokingly referred to that possibility. There were some pretty funny things about it. The second is chemistry. So, if I'm polluting SO2, you need to know how that affects the amount of acid rain that occurs. Or what are the effects of pollution on a lake, on that lake's chemistry, and the life that it will produce, et cetera. Epidemiology is another important area. So, for example, there are externalities if you get vaccinated. If I get vaccinated, I'm less likely to transmit a disease to you. You need to know a lot about epidemiology to know how large that effect is, and therefore how much you would want to subsidize the provision of vaccines. Another issue is ecological. If you kill off fish in a lake, how will that affect the whole ecosystem of that lake? Will that lead some algae to grow because the fish aren't eating them, and then shrimp will come in, and will that be beneficial, et cetera, et cetera. Or if we deforest an area, what are the lost ecosystem services that will come with that? That requires ecology. But as important as all these science issues are, they always require some sort of an economics backend. So for example, to figure out how costly the Fukushima Daiichi disaster is, we need to know something about what the value of the things were that it destroyed. And Wesley, how do you think we might, from economics, try to get a sense for, how harmful the Fukushima disaster was in terms of the land that it affected?
Well, I guess it would be the difference in the market value of the land before and after.
So that would be a simple way to try to think about the problem. That's not exactly perfect, of course, because it might be that the people who owned the land value it more than the market values it, and that there was some subjective value that they had that was destroyed even beyond the amount that the market value fell. But the market value might be a good first cut at that, right? A second question is, if you want to figure out how valuable the crops that are destroyed by acid rain are, you'd have to get some economic information. And Louis, what sort of economic information would you try to get to figure out the value of those crops?
So the market price of the crops.
Yeah, so there it's probably going to even be more accurate because most people do actually end up selling their crops, right? And so the market value is a closer approximation than it is with land, probably, of what the value is. A third issue is, how should we treat a small chance of a catastrophic outcome occurring? So to do that, we typically want to use something like expected value utility theory, using the fact that utility is concave, and therefore that like losses when we're already in disastrous state are much more costly than losses are today, and so you might want to put extra weighting on those states. So that's again how economic analysis would come into thinking about how costly that sort of a disaster would be. Or we might want to think about if we pollute a lake, that might destroy fish stocks and cost us the value of some fish in the future, but it might give us some economic value today. Wesley, what economic principle might you use in weighing those two things off against one another?
I guess the discount factor that you owe in the future and how that ties in with the interest rate.
Yeah, so the interest rate and the discount factor are ways that we try to weigh off the future against the present. And so that's one way that economics comes into thinking about how we trade off costs that come way in the future versus costs that come today, right? Economics might help us think about what are the value of various types of ecosystem services. And David Weyl, like how could economics help us think about that? The services supplied by an environment.
Like a natural environment.
Yeah.
Right? So I guess maybe like I don't know much about medicine honestly,
Yeah.
but like maybe the original like things that you get from the ecosystem that are put into medicine, and essentially like the destruction of whether or not that ecosystem would raise the prices of those natural resources.
Yeah, so you might try to think about what are what's the market value of some of the products that are available in that ecosystem that are not available elsewhere, or what are the potential innovations that could be based on something what's the probability of innovations, and what would be the market value of those innovations were they to come to market in terms of what the patent would be worth, right? So these are all areas where we have to take some inputs from science, but we also have to take some inputs from the economic theory of what those things would do, right? Another area is how much human lives or health that are ruined by disease are worth. And George, how do you think economics informs us thinking about that? The value of human lives.
I suppose whatever their economic impact would be on society would be a good starting point. So like how much they add to society.
Yeah.
Other than that, it seems to be very subjective because then their production in life is more of like the utility to other people, and it's kind of hard to measure.
Yeah, so I mean, one component of it is, as George was saying, just how much income they're going to earn, or how much their like marginal product to society is going to be. But I think a lot of people are uncomfortable with saying people's lives are only worth what they produce for society, rather than like how they value the lives themselves, right? And so what we're going to look at is how we can try to value that subjective component of what people, of the money value that people put on their own lives. Okay, so perhaps the most famous economic input, as I was just saying, is the value of human life. And a lot of people are uncomfortable. I think George is giggling at the beginning, or maybe I should call it giggling, chuckling, at the beginning of of my question, sort of indicates how uncomfortable we are with the notion that there's a value on human life. But if